In this video, I will show you how to calculate the volume of a sphere or a hemisphere or a combination of different kinds of shapes that we've seen. Here's a little snapshot of the formula sheet for this unit. These are all things that you need to know, so maybe pause the video and write down any of these formulas that you don't already know. But I think it's worth the time to commit all of these formulas to memory. Well, number one is just a straight up sphere. And the formula for the volume of a sphere is 4/3 pi times the radius cubed. So all we need is the radius. I see that the diameter is 18. That means that the radius is 9. So just putting that into the formula, I have 4/3 pi times 9 cubed. All right, so maybe I'll just put that in my calculator. All right, so the exact answer is 972 pi. So that's going to be 972 pi cubic inches. If I need the decimal approximation, that's going to be 3053.63. Did I say 3,000 or did I mean 30? Yeah, no, 3,053. All right, there it is. For problem number 2, this is half of a sphere. So look, if I were doing the volume of a whole sphere, it would be 4/3 pi times the radius cubed. Maybe I'll just write down the formula. 4/3 pi r cubed. So that would make this 4/3 pi times 27 cubed. However, this is not a whole sphere. This is half of a sphere. So I'm just going to take half of this. So I'm going to take half of all of this. All right, let's see what happens if I put this in my calculator. All right, so 1/2 of 4/3 pi times 27 cubed. Okay, 13,122 pi. All right, that's the exact answer in cubic centimeters. If I need the decimal approximation, that's going to be 41,223.98. $41,223.98. Got to round up. For problem number 3, we have a combination of two shapes. We have a hemisphere on top of a cone, and we want to find the volume of this. So look, I'm going to go ahead and identify this as volume 1, the hemisphere, and the cone, I will consider this to be volume 2, so you can follow along with what I'm doing. So obviously I can, if I know what volume 1 is and I know what volume 2 is, I can just add those together, and then that will be the volume of the overall shape, the combination of the two shapes. So that's my plan. So I'm going to go ahead and find volume 1 over here. So this is half of a sphere. If this were a whole sphere, I would do 4/3 pi times the radius cubed. So 4/3 pi 10 cubed. That's the formula for the volume of a sphere. However, this is not a whole sphere. This is half of a sphere, a hemisphere. So I'm going to take half of all of that, and then that should be the volume of shape number 1. So volume 1 will equal, let's put this in the calculator. So I'm going to take half of 4/3 pi times 10 cubed. Okay, so that's 2,000 pi over 3. Interesting. So that's 2,000 pi over 3. So that is volume 1. So now over here, I'm going to find now volume 2. Volume 2 is a cone. The formula for the volume of a cone is 1/3 the area of the base times the height. So, you know what? I like to calculate the area of the base off to the side. So hopefully you can see that this circle is the base of the cone. Alright, so that's what I mean by B. Alright, the area of the base is this circle. So the area of a circle is pi r squared, right? So the area of this base is going to be pi times 10 squared. So that's 100 pi. That's the area of the base. So I'm going to take that and put it in the formula right there. So that means that volume 2 is going to be 1/3 the area of the base times the height. The height of the cone is 15. Okay. So look, I'm sort of doing this in my head now, because if I look at 1/3 and I look at the 15, there's no reason why I can't multiply those together. So 1/3 times 15, 1/3 of 15 is the same as dividing by 3. So 15 divided by 3 is 5, and then 5 times 100 is 500. So volume 2 is going to be 500 pi. And probably my calculator will just do all of that anyway. So let's see. If I do 1/3 times 100 pi times 15. 500 pi. Fine. So now I have volume 1 and volume 2. So the overall volume, I feel like I should draw a line here. The overall volume is going to equal volume 1 plus volume 2. So that's going to be 2,000 pi over 3 plus 500 pi. That's the entire volume. Okay, so let's see what happens. So 2,000 pi over 3 plus 500 pi. So that is 3,665.19. Okay, and that's going to be cubic centimeters. For number 4, we have a hemisphere on top of a cylinder. So I will think of this as volume 1, and I will think of this as volume 2. So I'll find the two volumes and I will add them up. So let's start with volume number 1. Okay, this is half of a sphere. The volume of a sphere, the formula is 4/3 pi times the radius cubed. Now, the radius of the sphere is right here. And looking down, that's going to be the same as the radius of the cylinder, which is known to be 9. Okay, so the radius is 9. So 4/3 pi r cubed becomes 4/3 pi 9 cubed. Alright, now this would be the volume if it were a whole sphere. But it's not a whole sphere. It is half of a sphere. So let's see what that is. Let me see if the calculator will give me this as an exact answer. Alright, so that's 486 pi. Alright, notice that I don't turn this into a decimal yet. Always wait until the very last step before you make a decimal. Okay, so this is volume 1. Let's just keep that in the back of your mind. So now I'm going to go and find volume 2. So volume 2 is a cylinder. I know that the formula for the volume of a cylinder is the area of the base times the height. So volume 2 should equal, well, the area of the base is a circle. Alright, this is the base of the cylinder. And the area of a circle, in fact, I'm going to do this off to the side, like I often do. Maybe I'll do it right here. Alright, so I'm going to find the area of the base. I know that to be a circle, so that's pi r squared. So the area of the base is pi times 9 squared, because the radius is 9. So the area of the base is 81 pi. So I can take this area of the base and put it in right there. So I'll have now 81 pi times the height, which is 17. And this is volume 2. So volume 2 is equal to, 81 pi times 17. 1,377 pi. Okay, so this is volume 2. So, I know that the overall volume of the entire shape is going to equal volume 1 plus volume 2. So, that's what I'm about to do. Alright, so there's volume 2, so all I need to do is add volume 1. So 486 pi. Alright, so that is 1,863 pi. Okay, and the lengths were in inches, so the volume will be in cubic inches. And so that's the exact value. If I want the decimal approximation, 5,852 0.79, got to round up. And again, that will be in cubic inches. So that's the answer for problem number 4. Well, for number 5, we have a cone on top of a prism. So I will consider this to be volume number 1. and I will consider this to be volume number 2. So I will find both volumes and then I'll add them up. So let's start with volume number 1. Alright, volume 1 is just a cone. So I know the formula for the volume of a cone is 1/3 area of the base times the height. So too thick, man. Alright, it's 1/3 the area of the base times the height. Well, I really need to calculate the area of the base. So I'm going to do that off to the side. So here comes the area of the base. The base is a circle. Alright, here's the base right here. Okay, what I'm going to need, so the area of a circle, of course, is pi r squared. So this is the formula that I will use to find b. But I need the radius. Any ideas? The radius is going to be 4.5. 4.5. Okay, I can tell that because looking at this line right here, see that that's 9? That's just the diameter. That would be the same thing as the diameter of this circle. So that the radius will be 4.5. So anyway, the area of the base, the area of the circle, is pi times 4.5 squared. Well, let's see what happens if I put that in my calculator. 4.5, well, I'll put it in just like it is. Pi times 4.5 squared. Ooh, okay, they're giving me those decimals and stuff. I don't like that. What if I do 4.5 squared without the pi in it? Okay, that's 20.25. So I'm trying to write an exact answer for b here. So I have a choice. I can either put 20.25, alright, because that's what 4.5 squared is. And then I can just put a pi next to it, alright, so I squared the 4.5 and I kept the pi. That way I still have an exact answer to put right here. I don't want to round twice. Another thing you could do, if you're not comfortable with that, and maybe I'll go ahead and show the other thing I can do now, I can just put this entire expression in for b. Alright, I can put pi 4.5 squared, because that's what b is. So I could do that. I could just go ahead and put pi and then 4.5 squared. Alright, that's pi r squared. I can just put that in for b just like that to avoid the decimal. Now, the height of the cone is 10. Alright, so this is volume 1. Okay, I'm starting to be afraid that there's no way to avoid getting some decimals right now. If I put this in my calculator, I'm quite sure I'm going to get decimals. So I'm going to go ahead and do my best. So 1/3, because I really hate having decimals when it's not the end of the problem yet. 1/3 pi 4.5 squared times 10. Okay, here come the decimals. So here's what I would suggest. Did they tell us how many decimals we need on this lesson? 2 decimal places if needed is what they said. So if I were you, because it's not the end of the problem yet, even though in the end we want 2 decimal places, right now I would write down 4 decimal places. Just write down a ridiculous amount of decimal places. So volume 1 is 212.0575. Okay, just write down a bunch of decimals so that your answer will be accurate enough that you won't lose any points. So that's volume 1. So now I'm going to slide over to the right hand side, and now I'm going to find volume 2. So volume 2 is a prism, so the volume of a prism is the area of the base times the height. Okay, so this is a different base than I did over here, but I am going to calculate that off to the side. So the area of this base is it's a square actually. Alright, the base here is the very bottom of this prism, and that's going to be just 9 times 9. Okay, so 9 times 9, of course, is 81. So that's the area of the base, so that goes right here. So volume 2 is going to be 81 times the height of the prism, which is 5. Alright, so volume 2 is just going to be 81 times 5. So that's 405. Okay, so look, the overall volume of everything is going to be volume 1 plus volume 2. So that's what I'm going to do right now. Alright, so volume 1 is 212.0575 plus, and then volume 2 was 405. Let me just, yep, there it is. So I'm just adding them together. So that gives me 617.06. Okay, so this is in meters. So that's going to be meters cubed. So that is it for problem number 5. For number 6, we have a hemisphere on top of a prism. So I will consider this to be volume 1 for the hemisphere, and I will call the prism volume 2, and I will find these separately, and then I will add them up. So here I go. Volume 1. The volume of a sphere is 4/3 pi r cubed. That's the volume of a sphere. That's the radius right there. So what's the radius going to be? Because look, there's a circle right here. Okay, that's the that's the middle of this hemisphere. But what's the radius though? So this would be the radius, like right here. Well, I see the 8. Notice that the circle goes from one side of the square to the other. Well, I guess it's a rectangle, but it touches the sides. So in other words, the diameter of this circle is 8. Alright, it's 8 all the way across because of this right here is the same as this, which is the same as this. It's all 8 across. But that means that the radius will be 4. So the radius is 4. Alright, because it's half of this 8. So anyway, that makes volume 1. So volume 1 would be, I say would be 4/3 pi times 4 cubed if this was a whole sphere. But this is not a whole sphere. This is half of a sphere. It's a hemisphere. So I have to take the volume of a sphere and I have to cut it in half. So I have to take all of this. This is the volume of this, the sphere, the whole sphere, but I have to take half of that. So let's calculate what this is. So I'm going to get 1/2. Okay, 4/3 pi 4 cubed. Okay, will we get a decimal? No, we did not. Great. 128 pi over 3. All right, don't make a decimal if you don't have to. So 128 pi over 3, that is volume 1. So now over here, let's do volume 2. The volume of a prism is the area of the base times the height. So let's calculate the area of the base first. Well, the base is this rectangle that's down here somewhere. Okay, I didn't do a great job of drawing it, but this is the base right here, this rectangle. And the area of a base, the area of a rectangle is base times height. So that's going to be 8 times 12. All right, so that is going to be 96. So that is the area of the base. So that means volume 2 is going to be 96 times the height of the prism, which is 10. Which gives me that volume 2 is going to be 960. All right, so I have volume 1 and I have volume 2. So look, the overall volume is going to equal volume 1 plus volume 2. So that's what I need to do right now. I'm going to take 128 pi over 3, and I'm going to add 960 to it. All right, volume 1 plus volume 2. All right, so that is 1094.04. cubic centimeters. So that is the answer for number 6. All right, tennis balls with a 3-inch diameter, not radius, are sold in sets of 3 as shown here. Assume that the container is a cylinder. We're going to round the answer to 2 decimal places. What is the volume of one tennis ball? Well, a tennis ball is a sphere. So the diameter of the volume of a sphere, you know what, I can use bigger ink now because I zoomed out. Okay, so the volume of a sphere is 4/3 pi times the radius cubed. Okay, so if the diameter is 3, then that means the radius is 1.5, right? Because the diameter is the distance all the way across. So if that is 3, then the radius is going to be half that, and that is 1.5. So that means I've got the volume is going to be 4/3 pi times 1.5 cubed. That's the volume. So let's see what that is, man. Let me make space. Okay, to the calculator. We have 4/3 pi times 1.5 cubed. Boom. All right, so that is 14.1372. Let's see, this was inches, so that's cubic inches. Now, this would round to 14.14. If I do 2 decimal places, 14.14 cubic inches. The only reason why I even wrote down those extra decimals is just in case we need to use this number later, and if I wanted more accuracy. Okay, what is the volume of the can when it is empty? So just ignoring the tennis balls, the can, we're supposed to treat the can as a cylinder. So what is the volume of a cylinder? So the volume of a cylinder is the area of the base times the height. Let me sneak in a little bit of space to the left. Okay, the volume of a cylinder is the area of the base times the height of the cylinder. But before we can do this, we need to figure out what the area of the base is. So the base is a circle, right? If I were to look at the top of this from above, all right, that base would be a circle. And the area of a circle is pi r squared. So again, I need to think about what the radius of this is. There seems to be a little wiggle room for these tennis balls, but I think we're supposed to assume that the tennis balls, touch both sides. Okay, so even though that's not 100% true, that's going to be a pretty good estimate. So let's pretend, let's imagine that the radius of the can is the same as the radius of a tennis ball. And we found that radius to be 1.5. Remember earlier, because the diameter is 3, and half of 3 is 1.5. So that's going to be area of the base is pi times 1.5 squared. So I think I'm going to leave that just the way it is for right now. So this is going to be a nice expression for the area of the base. So the volume is going to be pi times 1.5 squared, it's area of the base, times the height. What is the height of this can? They don't tell us the height, but if we assume that the tennis balls reach all the way to the top, right, and fill this can, well, remember, each tennis ball has a diameter of 3 centimeters. All right, so this tennis ball right here, that's inches. I said centimeters. That's 3 inches. And we have another tennis ball, that's another 3 inches. And we have a third tennis ball, that's another 3 inches. So how tall is the entire can? That is 9 inches, all right? Just if I'm looking at the stack of tennis balls. So that's the height of the can, so I can just go ahead and put 9. All right, so I think that's enough information for me to go ahead and get the volume of the empty can. I'm going to use my calculator. So I'm going to do pi 1.5 squared times 9. All right, so that's 63.62. Got to round up. All right, cubic inches. All right, so I have the volume of a single ball. I have the volume of the empty can. Now what? How much space is not occupied by tennis balls in the can? Okay, so we are looking for the amount of empty space. Like basically, if I were to pour water into the can around the tennis balls, and the water were to come in here and just fill in all the cracks, like this. All right, water just filling in all the cracks. The question is, how much water would there be, okay, filling up these cracks? What would be the volume of water? We can subtract. Okay, the space around the balls is going to be the entire volume of the can minus the volume of the tennis balls. Okay, all 3 tennis balls. So let's check this out. Okay, so the volume of the space is going to equal the volume of the can minus the volume of the tennis balls. Now remember, a minute ago we found the volume of one tennis ball, but we need to subtract the volume of all 3 tennis balls if I want to know the leftover space. Okay, so just keep that in mind. 3 of them. Alright, so the volume of the space is going to equal the volume of the can, the empty can. So that's going to be 63.62 minus the volume of 3 balls. So let's see. A single ball has a volume of 14.14. But I went ahead and tripled it because there's 3 of them. Alright? That's why there's a 3 right here. Alright, but anyway, if I do this subtraction, that should be it. Alright, so let's see. The volume of the space equals 63.62 minus 3 times 14.14. 21.2. Okay, and these are cubic inches once again. So that would be the final answer for number 7, part C. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.